Time, it shapes our lives. We measure it in seconds, minutes, hours. But what is time, really? Is it an invisible river that flows unstoppably, or an elastic dimension that can be bent? From Newton's absolute clock to Einstein's curved space-time, the mystery of time is the story of a mental revolution that redefined our universe. In the 17th century, Sir Isaac Newton laid the foundation of classical physics. For him, time was absolute. It flowed evenly no matter what happened. Like a perfect, invisible clock in the background, ticking exactly the same everywhere in the universe. This picture worked. It explained the orbits of planets, the movement of apples and cannonballs, and made the world predictable. But in the 19th century, cracks in the model began to show. James Clerk Maxwell showed light has a constant speed, about 300,000 kilometers per second. No matter if you run towards the light or away from it, its speed stays the same. This went against Newton's idea of a fixed stage of space and time. If light is always the same speed, something else had to adjust. Maybe time itself? In 1905, Albert Einstein arrived. He dared to take a radical step. Space and time are not separate. They form a single unit. Space-time. Imagine space-time as a four-dimensional fabric. The three dimensions of space length, width, height, and time as the fourth dimension. An event, whether it's a birth, a supernova, or a drop of water, can only be fully described if you say, where in space and when in time. In this fabric, time is relative. If you move very fast, your time axis tilts. Your clock ticks slower, an effect we call time dilation. This sounds abstract, but it has real consequences. Astronauts who spend months in orbit age slightly slower than people on Earth. Not noticeable in everyday life, but measurable. Einstein went further. In 1915, he formulated the theory of general relativity. Here, space-time itself becomes the actor. Imagine a stretched sheet. If you place a heavy ball on it, a dent forms. The sheet represents space-time. The ball represents a mass like the Earth or the Sun. If a smaller ball, like a planet, moves across this sheet, it follows the curves. This is gravity. Not an invisible force, but the curvature of space-time. And time is embedded within it. Near a mass, time passes slower. A clock on Mount Everest ticks faster than a clock at sea level. GPS satellites at an altitude of 20,000 kilometers run so much faster that they need to be corrected daily. Otherwise, our navigation system would completely fail. With Newton's absolute time, we could calculate a mechanical world. With Einstein's space-time, we understand the dynamics of the universe. Black holes, gravitational waves, even the expansion of the cosmos. But the biggest question remains unanswered. What is time? Why does it have a direction from past to future? And why can't we reverse it? Some physicists suspect that time might not be fundamental at all, but an illusion that only arises from the structure of the universe. From Newton's eternal clock to Einstein's space-time, our understanding of time has changed radically, and yet it remains one of the greatest mysteries of science. What do you think? Is time really real or just a product of our consciousness? Share your thoughts in the comments and subscribe to our channel to discover even more fascinating mysteries of the universe.